Kia ora, Year 12 and 13 and Year 11. Here's question 2E from last year's Differentiation Level 3 Calc paper. So this is an excellent question about a cone and a rate of change to do with the surface area. We've got a water tank that is in the shape of an inverted right circular cone, and we're told that the height of the cone is 200 metres and the radius of the cone is 80 centimetres. The water in the tank is filling up at a rate of 150 centimetres cubed per second. Now we have to find the rate at which the surface area of the water will be increasing when the depth of the water in the tank is 125 centimetres. So I'm going to call the depth H and I'm going to call the radius R. Now when you're doing a problem like this, there are two things that come up every single time. The chain rule, so we have to start by setting up a chain rule relationship. And one of the following three things usually pops up, either Pythagoras, so I'm just going to draw some triangles. Right, so Pythagoras comes up, or trig comes up, another triangle. And the last thing that comes up, and this is the one I'm going to use here, is the idea of similar triangles. And the way you can see some of the triangles going on in here is that we know that that cone, the water tank, if it were completely full up, would have a radius of 80 and a height of 200. And it won't be full up most of the time, but no matter where the water is up to, the ratio of those two things, the height and the radius, is going to be the same. So we can write that like this, that if we've got 200 over 80 when it's full, that must equal the height over the radius. And that means that I can get rid of one of the variables. I can eliminate either H or R, but we'll get to that in a minute. So let's see what we know. Well, we've got a derivative here. The tank is being filled up with water at a rate of 150 cubic centimetres per second. So that tells me that dV by dt is equal to 150. Now we're probably going to want to know how we find the volume of a cone. And the volume of a cone is given by this formula. So it's 1/3 pi r squared h. Now that'll be on your formula sheet, but it's one that you should be pretty familiar with. And the last thing that we're looking for is, what do we have to find? Well, we have to find the rate of change of the surface area with respect to time. So we're looking for dSA by dt. So we need to have an expression for the surface area. Now the surface area of the water tank is just the circle sitting on top of it. So let's write that down. So SA, or just A, is equal to pi r squared. The last thing we need to do is to set up a chain rule link. So we're looking for dSA by dt. Let's see how things link together. Well, I can figure out easily how the radius and the surface area are linked together. So we're going to easily get dSA by dr. And at the end, we need to have dt. The missing piece of the puzzle is the volume, right? So here we're going to have dr by dv, and here we're going to have dv by dt. So I did that pretty mechanically. I didn't think about anything weird with water filling. I just looked at this and said, well, I need to end up with a dt here, and I'm going to start with an SA here. The surface area is defined in terms of the r, so that's going to give me dSA by dr. And then we just work backwards, and we figure out that the v is going to sit in here. So what do I have to do now? Well, I have to go back and find my volume expression, which is this, and see if I can get out of that dr by dv. Remember that dv by dr and dr by dv are just reciprocals of each other. So if we can find dv by dr, we're just about there. And the key to it is to say that we have to have our expression in terms of one variable. So we don't want this h in here. But we've already seen by similar triangles that h and r are linked together in this relationship, right? So 200 over 80 is equal to h over r. So let's do something with that. 208 over 80 is equal to h over r, which means that h is equal to 5 over 2r. So V is equal to 1/3 pi r squared times 5 over 2r, giving me 5/6 pi r, just pi r cubed. Let's change the pen. So dv by dr is equal to 15 over 6 pi r squared, and we can clean that up as 5 over 2 pi r squared. That means that dr by dv is equal to 2 over 5 pi r squared. So let's go back to chain rule and see what we've got. Well, we've got dsa by dt is equal to dsa by dr. Now I know this is a little bit repetitive, but if you're bored, just forward through it. Now we've got all of the bits we need because SA was pi r squared. So dSA by dr is simply 2 pi r. So just pop that in there. So we've got 2 pi r times 2 over 5 pi r squared times dv by dt is 150. So a few things cancel out in here. We end up with 600, the pi's go, 600r over 5r squared, working very slowly through this, is equal to 120 over r. The last thing I have to do is figure out what r value we're interested in. So let's go back to the question and have a look. Well, we have to figure out the surface area when the depth of the water is 125. So h is equal to 125. Where are we? Here. H is equal to 125 and r is equal to 2/5 of h, so r is equal to 50. That gives me dSA by dt is equal to 120 over 50, which is equal to 2.4, and the units are going to be squared per hour, I think. No, per second. So centimetres squared per second. So there you go. Right, so it's a really nice example of a related rates of change problem. It's got a chain rule thing in it, and it's got 3 bits in it. And if you spot the similar triangles thing, it really isn't too bad because that lets you eliminate one of the variables. So there are lots more of these in old exam questions. If you're looking under the playlist and you go to the expired standards video, you'll see quite a few more of them there. Thanks for watching.